Okay students, now we'll give one example or all for everything, right? I told you, whenever you talk about pedigree analysis, 4 types of possibilities are there. So I have given all the 4 possibilities, whether it is the recessive or dominant, and if it is recessive or dominant, is it autosomal or it is allosomal or sex chromosome, right? Now, I have given you 4 different types here. You can see first one is, so this is how to solve the pedigree problem. Means you will get it in the examination, one chart will be given like this and they ask you to identify what it is representing. You will get only this much. So before that I have given you some clues, identify. What is the clue to identify? First one, in autosomal dominant disease. If it is autosomal means not the sex chromosome, somatic chromosome, those 44 chromosomes we have now. Those are the autosomes. If it is autosomal dominant disease, then what are the patterns of inheritance? First one says, it will not show any skip generation. So as I already explained in sex-linked inheritance, there is something called the skip generation inheritance, right? In hemophilia, color blindness and all. But here, there is no skip generation inheritance. Okay. Second is, in every generation, one is affected. Means, whatever it is, one of the individual offspring is affected. Then both the parents are affected but the child may be unaffected. So among all the 3, one may become right for you. Right? So example is Huntington's disease. It's called Huntington's chorea. It's a kind of disorder in which the person will have no balance of the body. Huntington's chorea, they will have normally the movement of the body parts like jerky movements, right? Like you have seen Huntington's chorea, normally it is tested in old people, elderly people and all. They can't take the hands and things up easily like this. There will be a jerk-like movement. It's called Huntington's chorea. It means a kind of dance. It's actually a kind of dance in which, like a break dance, it's part, they'll be moving. That is the example for this autosomal dominant. It's a disorder, right? So see this example 1. You can see you have analyzed already. I told you how to analyze it. So first I showed male and female, both are, I showed a solid ones. Male is square, female is circle. Both I showed the darkening things, means both are affected, right? So what I said, they don't show skip generation. In every generation one is affected. You can see here, when they are producing children, 2 children are both male and female are affected, right? One is at least affected. But one more clue I given is, although both parents are affected, one child may be unaffected. See, this is the clue. So therefore I made a question mark. So whenever you see this chart, suddenly you should go through such clues, right? Where you will get an answer, right? So there is a clue where parents are affected. Although some children are affected, one of the male is unaffected. It is not affected. This means, this is the clue for you saying that it must be autosomal dominant. See, these clues you just by heart, right? Like by heart, okay? They don't show skip generation inheritance. Means every generation one is affected, but there may be a child which is not affected, although both the parents are affected. This is the clue here. Parents are affected, child is not affected. Here you can see another family. Female is unaffected, male is affected, father is affected, mother is unaffected, but father, next generation one is affected. I told you, if the one of the parent is affected, definitely next generation one more child will be affected. Right? It may be male, it may be female. There is no differentiation of male or female. The distribution of disease is same. Right? Therefore, don't think it's like I told you, sex-linked inheritance where only females are carriers, males. No, here nothing like that. So you can see father is having disease, but female, their daughter is normal, but the male or their son is affected, right? So that's a clue. There will be every generation one is affected, right? It is affected. But both the parents affected, the child is not unaffected, it's not there. But now you can see it. Here both are unaffected. So children all are unaffected. Remember, this is a very important clue for you. The parents are affected, then child will be definitely affected. One second, just hold it. Okay, you can see here, as I told you, what is the clue I said? The parents are affected means one of them or both of them, children will be affected. So that is the autosomal dominant character. But one more clue is, Sometimes although parents are affected, one child may be unaffected. That's another clue which is showed here. You can see both are affected, but the one of the child is unaffected. So male. But anyway, male and female is not considered here because all are same. Male or female because it's an autosomal disorder. Autosomal somatic chromosomes. They don't differentiate the males or females. But in this, you can see in this parent, father is affected, but the son is affected here. But if both the parents are normal, children, see, 2 sons and 1 daughter, all are normal, right? This is the first generation, this is second generation. This is the clue for autosomal dominant inheritance, right? The example for this is Huntington's chorea. I told you Huntington's disease also we call it as. Now, second type of inheritance, it is autosomal recessive. Autosomal recessive means it remains a recessive condition. What are the characters I gave you? Skip generation inheritance is observed. Means one generation it is affected, person is seen. Next generation it disappears. Third generation it reappears. Fourth it will disappear. This is called skip generation inheritance. Means if it is autosomal recessive, then there is a skip generation inheritance. 100%. Again you may confuse with the sex chromosomal recessive. But how is a clue? Just check it. Unaffected parent can have an affected child. If the parents are unaffected, still the child can have. This is not possible with the sex-linked inheritance. Okay? Unaffected parents are there, then the child is see. You can see, look at this once. You can see here, this is unaffected, this is unaffected, but the child, one of the child in their family is affected. See? Both, although these are, see, this is a clue, you have to look at the clue in that. So it's little thing to worry, right? Think once you concentrate on that. Okay, you can see here, it will show skip generation inheritance, right? But here I have not shown any skip generation because both here one is affected, one is unaffected. Next generation, one girl is affected, boy unaffected. So skip generation you want to show, that means it skips a generation. But here I showed the affected ones. Therefore, skip generation is not seen in this. But what is the clue here? Unaffected parents can have an affected child. That is seen here, right? See, you can have one clue or all the clues in the chart, right? This clue will be working here. So, although 2 parents are not affected, the one of the child is affected. Therefore, it is the autosomal recessive. You can see here, you can analyze it. Male is affected, female is not affected. They produce children, that is female, male, and one female, one more female. Female is affected. Then the cousin marriages, if it happened, again the male is affected, female is unaffected. So it is not. I am not showing any skip generation here because skip generation means one should be having no effect. One next generation it should affect, right? But here what works is unaffected parents. See, these are 2 parents. This is one family, this is another family. This have a normal female, this is a normal male. If they get married, still she might have got the gene from her father, it is affecting her son. This is the indication that it is a autosomal recessive inheritance. The example for this is cystic fibrosis. It's a kind of disorder happening in the genetic disorder happening in the lungs where and it affects the respiratory and this digestive system also. This is the second autosomal recessive character. Then third one is right. It is a allosomal or sex-linked dominant inheritance. What is that? Sex-linked dominant inheritance. Where disease never transfer from father to the son. Very important word. What is that? Disease will never come from father to son. First thing. Second is father to daughter and mother to son transfer happens. That is father to, it will not go to son, it will go to daughter. But from mother it goes to the son. That is the way it is transferred. If father is affected, all his daughters are affected, right? Means if the father once it get affection, he get the infection or he get the disease and all his daughters are affected but not the sons. See, example is vitamin D resistance, that is in rickets. Okay, let's come to the third one. I told you it is allosomal dominant. What is allosomal? Sex chromosome inherited, but it is dominant. What is the clue in this? Disease never transfer from father to the son. Means any disease you take it, Here disease they have given vitamin D resistance, that is causing rickets. Right? This will never transfer from the affected father to the son. But he transferred the disease to all the daughters he is producing. And mother transfer the disease to her son. Father to daughters, then the mother to the sons. It transfers. Right? If father is affected, all his daughters are affected. Example is vitamin D resistance, that is causing rickets. Now see the cross. See, the father is affected, mother is unaffected. See, all the females are unaffected, but son is not affected. Right? You can see 1, 2, 3, 3 children are there, 3 daughters are there, all are unaffected. Sorry, they are affected because they have got it from the father. Because they get X chromosome from father, right? I'll learn how to write the cross. XXXY, na? 1X they get from the mother, 1X they get from father. But father's Y chromosome go to son. If he has the allosome, X chromosome affected, then he will not give the X chromosome to the son. Therefore, all the girls who are getting that X chromosome are getting the disease. Therefore, it is allosomal dominant, that is X chromosome is dominant. Then son, see here, he is not affected. See, 1, 2, 3, 4 children are there. All the girls are affected, son is unaffected. Right? Now, if this female married to the normal man, then next generation, she transfers it to her daughter. Right? But there is an affected individual also there, but it has come from the mother only. Right? Mother transfer the disease to the son. Right? And then here it is transferred. The clue you have to get. What is the clue? Father affected, he transferred it to the daughters. Right? Here mother affected, here it should be clear. If mother is affected, she will transfer the disease to the son. Then father affected, he transfers it to the daughter. This is the way you have to identify. And now you can see this is a cousin marriage. The mother affected and father is unaffected. Mother will transfer to her 2 daughters, 1 son, right? And father is not transferring, it is there. The gene is there with them. So with her, 1 X chromosome, it goes to her also. So in this again you can see mother is affected, the female, male, female, all are affected. Means wherever the X chromosome with the disease is transferred, there and all the disease is transferring. Means if at all it is related to the mother is having X chromosome, 2 X chromosomes. If she is affected, she has both affected chromosomes, X dash you can take it. Right? If you want to take the XX, she is affected female. And if she marries to the normal man XY, then wherever this X grows, right, she produces 1 gamete, he will produce 2 gametes, then these 2 combine X dash X. This is unaffected female, but if she transfers X dash Y, it is a affected individual. Right? If both are affected, right, he also is affected, he also affected, then it will transfer. You can see here, this is affected. If this is affected, this she will get disease. Right? And if this is a cross, he is also affected. So as a clue I gave you, one clue you have to identify in this whole cross is this first clue. What is the first clue showing? Father affected, all the 3 girls are affected, boy is not affected. This is the first clue. Other things, maybe they have got genes from some other area, but one clue you have got, you should write it is autosomal dominant disorder. Last one you know already, allosomal recessive disease. That means it is allosomal, means sex chromosome, sex-linked inheritance. It's showing skip generation inheritance. And in this allosomal, males are affected normally. Probability for getting males, the disease is more. Already we had discussed earlier about this. Because hemophilia, when it is there in the parents, if at all it is mother is affected, the father is affected, she will transfer the disease to the daughter. She will be a carrier. Right? You can write this is affected female, the normal male. Then she transferred to the son. Right? Then sons, both sons are affected. This is a clear indication. Both sons are affected from the mother, it is sex-linked recessive gene. Right? Then if they get married which are diseased, all are diseased. But if such females are, these should be carriers. Actually, you can write even carriers like putting them half like this. Right? Half of it. One may be carrier female. If they marry a normal male, again she will transfer the disease to another male. This is what you have written already, sex-linked inheritance, you have written the cross. Looking at this, you can easily analyze, right? So all the 4 types, you just go through various examples given in your NEET book and analyze this. This is very, very important thing for you. For one at least question, either in CET or in NEET or AIMS examination, wherever you go, you will get it, right? So once again you go through this, you take a pic of this. I'll just move away from this, take a pic and keep it with you. Anytime it will help you. Okay? Done then. Okay students, this is whatever I explained you till now. It is the first part, that is about the Mendelian inheritance, principles of inheritance. This is ending here. Although mutations come under this, I will explain you mutations only when I finish about the genes and structure of genes. Okay? Let us now start the new unit, that is molecular biology. Right? Before that, let me give you some of the PU board questions appearing from this. Right? Let us learn, or I'll give you the board questions, and I want you to write the answers for these. Okay? And keep it. Right? Already Mendelian inheritance I have given you. Right? What is left is the question of 1 mark. What is defined linkage? What is crossing over? From here I have not given you crossing over. Definition of linkage and crossing over. Then second is 5 mark question. Write a note or describe linkage and percentage of linkage in Drosophila. Drosophila, you are going to write the complete chart and give the explanation how the linkage has happened. Then third one I gave you about the blood groups and all I have given you, that is under multiple alleles. Define multiple alleles. Multiple alleles, you have to definition, you have to write alleles. Then fourth one you may get who are the universal donors in the blood groups and who are universal recipients. Okay, universal donor blood group and universal recipient blood group, and why are they called so? That's an important question, right? Then fifth one, it is about the inheritance of blood group. Write the genotype of various blood groups in human being. This you have learned it already, right? That's about the linkage and crossing over and multiple alleles. Then next question is about the sex determination. Explain the process of sex determination in humans or birds or insects. A 2 or 3 mark question. 2 to 3 mark question. Right? Then seventh is write a note on sex-linked inheritance. Sex-linked inheritance, and explain the pattern with an example like hemophilia. Okay? Then they will give you one of the pedigree analysis. What is the meaning of pedigree analysis or chart? And they will give you a pedigree. You will have to write the meaning of that pedigree and what it represents. You have to write these. Okay? These are some of the board questions I have explained. Okay? Now let me give you some of the NEET questions from your NEET book. Okay? Let's go through your Transcend book and discuss the NEET questions on this chapter, that is about Mendelian inheritance and the sex-linked inheritance on the basic types. Right? So let me start off with the NEET questions on principles of inheritance. Next is molecular basis of inheritance. I am going to start with the next class, in the next class. Let me solve some of the questions and finish the chapter, and you need to solve the remaining questions. Okay? So that's how we were doing all this time. So let us start with the the Mendelian inheritance, the first part. Okay. So you are going to start with the Mendelian inheritance. Okay. So just have the questions with you. Some of the questions here and there I'll discuss, and later we will discuss the details of all of it. Okay. Okay. Principles of inheritance and variations. Let's go to the first question. Mendel proposed that the factor controlling any character is discrete and independent. This proposition was based on, means on what basis he said that factors controlling any character is discrete and it is independent. First answer says results of F3 generation of a cross. Second says observation that the offsprings of a cross made between the plants having two contrasting characters show only one character without any blending. Third is self-pollination of F1 offsprings. Fourth says cross-pollination of parental generation. It's very easy clue for you. It is based on the observation that offsprings of a cross made between the plants having two contrasting features show only one character without blending. So we are talking about neat questions on the principles of inheritance. First unit, principles of inheritance. We are going to take the book and start working, right? Second question says, in a dihybrid cross, if you get 9:3:3:1 ratio, it denotes that, what will it indicate? So if this is the second question, if in a dihybrid cross, if you get F2 ratio as 9:3:3:1, what is the meaning? What will it indicate? First one, the alleles of two genes are interacting with each other. It is 100% wrong. They will not interact. He never knew interaction of alleles or linkages. Second is, it is a multigenic inheritance. Okay, let us go through the second question. Okay, second question is saying what is that indicating 9:3:3:1? What it indicates? First one is alleles of two genes are interacting with each other. So in a dihybrid cross, if you get 9:3:3:1 ratio, what it indicates? First one, alleles are interacting is wrong, because alleles, if they interact, they will not show independent assortment. Second is, it is a multigenic inheritance. No, it is a Mendelian inheritance where he never took multigenic inheritance. He only said that the a pair of alleles only control a character, not multiple alleles. It is the case of multiple allelism is wrong. The D says the alleles of two genes are segregating independently. How you identify in a dihybrid cross? Whatever this 9 and this 1 is the parental combinations. How many are getting parents? Parental combinations you are getting 9 plus 1. 9 is the dominant one. This is the recessive. So it's totally 10 are parents. But what are the recombinants you are getting in this? Recombinants are 3 plus 3. These are indicating the alleles have undergone independent assortment. Therefore, it is not a interlinkage. It is an example of the independent assortment of alleles in a dihybrid cross. Okay, let's move on to the third question. In antirrhinum, that is the dog flower we call it, or what do we call it as almost sweet pea we call it, antirrhinum. Phenotypic ratio in F2 generation would be, right? That's the same thing what you get it as incomplete dominance, right? Keep that in mind. That's why if you don't understand the name of the plant, then it is very difficult for you to analyze the answer. So this is again the same character as that of our plant, what we get it in Mirabilis jalapa. So what you will get, phenotypic ratio in F2 will be not 3:1. 3:1 is a pure dominance. You will get 1:2:1, which indicates it's an incomplete dominance. 1:1 is a test cross ratio. 2:1 is never getting. Right? All the ratios you have to remember here. If at all you write 3:1, first ratio 3:1, it is a F2 monohybrid phenotypic ratio. These ratios you will remember. Then 1:2:1, normally you get F2 monohybrid genotypic ratio. But what they are giving is 1:2:1 as a phenotypic ratio. Phenotypic ratio, if it comes to 1:2:1, this must be due to incomplete dominance. This is how we have to calculate incomplete dominance. Right? Then if you get 1:1, it is the ratio for test cross. All you remember. It is in monohybrid cross. If you get 1:1:1:1, this is the test cross ratio for dihybrid. This is how you have to remember. Then what else you have learned? 9331. What is this? It is the F2 dihybrid ratio, phenotypic ratio. But if you get 1:2:4:1:2:1:2:1, this is the F2 genotypic ratio, the whole thing, ratio of dihybrid cross. So all these ratios you remember. First ratio, second ratio, third, fourth, fifth, sixth, seventh. All these ratios should be in your mind all the time. If you solve certain problems, because nowadays I am seeing most of our students are sending me the solved questions. They are all solving monohybrid dihybrid process and sending me. I am very happy about that because they are working out. But still I expect all of you to do it. Hardly around 10 to 15 children are doing it, and others are asking questions also. This is a great thing from your side. You are really working hard. I am very happy about this, because unless you work out these problems, you will not get the answers, and you cannot write it also in examination. Even while writing or sending me also, with all the care they have taken, so many times they are missing so many things. Means sometimes they will not circle again. Sometimes they directly cross the hybrids. You have to take selfing, they will not do. So like small mistakes happen only when you conduct the class. You do the crosses. Otherwise you will not get it. Right? It's very difficult. It's not a story. Right? So many times students will think biology, okay, I'll read, I'll remember. No. This chapter, it's not possible. You will have to work out. Right? Next. Fourth question. All genes located on the same chromosome. Right? If all the genes are located on the same chromosome, A option is saying form different groups dependent upon their relative distance. Right? All the genes, if they are located on the same chromosome, option A is saying form different groups depending upon their relative distance. Second is saying form one linkage group. Third says do not form any linkage group. Next says form interactive groups that affect the phenotype. Normally, if most of the genes are located on the same chromosome, they may undergo linkage. Therefore, that is the B option. Then, fifth question you see, ABO blood groups in human beings cites the example of. What will it explain? First is saying incomplete dominance, first option. Second is codominance. Third is multiple allelism. D is saying both B and C. Actually, if you take ABO blood group, then it is only multiple allelism. But if you take AB blood group, it is codominant. Because AB is IA, IB, both are codominant, so it shows codominant. Therefore, the example D is right because it is saying both B and C are correct. It's right. Right? Next, distance between genes and percentage of recombination shows. Means, if the distance, how big is the distance and how many recombinants are formed, what will it show? First says is a direct relationship. Right? That is, it shows how much they are related. If the distance is so much, so many recombinants are formed. Suppose the number of recombinants are more, that means genes are far away. Recombinants are less, then genes are linked. That's how you will get the first answer. It's a direct relationship. Means number of genes, the distance between genes and percentage of recombination has direct relationship. Second is saying an inverse relationship. Not so. The distance between genes is small, recombination is less. If the percentage of recombination genes are distance is more, then recombination is less. Just a minute. So let me clarify this question, because linkage and crossing, although we have done it, once again I would like to clarify the doubts. Okay. So imagine this is one chromosome on one. If the genes are here located far away, another is here, genes are far away. In them, although they cross over, right, like this they cross over, what happens? Recombinations are more. If they are far away, the percentage of recombination is high. But imagine there is one gene, another gene here, same way, homologous chromosome, another gene. If they cross over like this, there is possibility of that both genes together they go. So percentage of recombination or recombinance is low, right? Parental combinations is more. So that's how you will get an answer. So therefore here they are directly related. Means the distance between genes and percentage of recombination are directly related. Next, to determine the genotype of a tall plant of F2 generation, Mendel crossed this plant with a dwarf plant. What is this represent? See, this all these things, whenever they say it, you should just take it down, right? The next question, that is about the question number 7, I think. So what is the 7th question saying? You just take it down. What is that they are saying? To identify the dominance genotype of tall plant. So there is one tall plant. It is dominant character in F2 generation. It is from the F2 plant, F2 tall plant. Whether it is dominant or is it homozygous or heterozygous, you don't know. What he did was, he crossed the plant with a dwarf plant. Right? If you cross the F2 dominant parent with the recessive parent, what do we call this cross? This kind of cross F2 is a hybrid. Hybrid with the dwarf plant you are crossing, that means it must be a test cross. Because you are getting F2 tall, they are saying clearly, it's a hybrid tall. You are taking and crossing with the dwarf, you get 1:1 ratio, which is indicating it is a test cross ratio. Right? Whenever they say hybrid of F1 or F2, if they are crossed with the recessive parent, that means it should be a test cross. Okay? Next. Back cross also they are given, reciprocal crosses are they given. So what do you mean by reciprocal crosses? Reciprocal cross, most of the students will be having doubt. What is this reciprocal cross? If you take the male parent as tall plant and female parent as dwarf plant, this is first cross. This is a normal cross. In reciprocal cross, we take the male parent as dwarf and female parent as tall. This is the reciprocal. This is a normal cross. If you take the change in sex, it is called the reciprocal cross. Right? So that's why reciprocal cross also is given. It's not a hybrid cross. So answer should be the test cross. Next is, which of the following, 8th question, will not result in the variation among siblings? In siblings, I hope you know, siblings are born to the same parent. They are having brothers and sister relationship. Which of the following will not result in variation among the siblings? First one says, independent assortment of genes, crossing over, linkage, mutation. Which of the following will not result in variation among the siblings? Due to which you will not get variations in the siblings. Right? Means parents, although they have some character, why there is no variation among them, it will not result in siblings. It's crossing over resulting in variations among the siblings. If there is a crossing over, there will be variation. Right? If it is independent assortment also, there will be variation. If there is mutation also, there will be variation. Only during linkage, you don't get the variations. Therefore, the answer should be linkage. If the genes are linked, then the siblings will look alike. If you have the example character, father character, if he is tall with the straight hairs, imagine. If those genes are linked in father, then in the offsprings, if all the offsprings are having tall stature and straight hair, that means those genes are linked. There is no variation among the siblings. It means all brothers and sisters have the same character. That means they are showing linkage of characters. Okay? Now, next is 9th question. When two pairs of traits are combined in a hybrid, segregation of one pair of characters is independent of the other pair of character. The statement explains which following laws or principles of inheritance in Mendelism. So this is a very clear thing which we have discussed already. Then you can directly write it is a law of independent assortment. They are saying two pairs. That is the first clue you will get. Two pairs of traits are combined in a hybrid. Then when they produce gametes, segregation of one pair of character, one pair of allele is independent of the other pair of allele. This means that alleles are undergoing independent assortment. It is the second law of Mendel. That's law of independent assortment. Okay, I hope you understood. Next is 10th question. Some of the dominant traits are studied by Mendel. Who are those? What are those characters studied by Mendel? First is round seed shape, green seed color, axial flower position. Right? This is studied. Okay. Terminal flower position, green pod color and inflated pod shape. Violet flower color, green pod and round seed shape. Wrinkle seed shape, yellow pod color and axial flowers. So among these, what he considered as dominant traits you have to identify. See, if you take the round seed shape, it's dominant. Green seed color, it is a recessive, so it's not a dominant. They are saying which is a dominant trait among this. So axial flower is a dominant. So first option is gone. Second option says terminal flowers, green pod, inflated pod. Inflated pod is dominant, but green pod is recessive. Terminal flower also is recessive. Then third says violet flower. That's what I call it as purple or violet color flower. Green pod, violet flower, green pod, round shape. Right? Pod color. Pod is the fruit color. So all these three are dominant characters. So that will be the right thing. The option C is right in 10th question. Now, among the 7 pairs of contrasting traits in pea plant as studied by Mendel, the number of traits related to flower, pod and seed, how many are there? Right? Means they are saying 7 contrasting characters studied which are connected with pod, flower and seed respectively. Right? So what are the characters studied? Let us list all the 7 characters studied by Mendel. Right? They said flower. We studied the 2 characters of flower. Right? We studied flower character. 2 characters he studied. Flower. What are we studied? First he studied the color of the flower. Second he studied the position of the flower bud. Okay? Then about the fruit or the pod. What is studied in pod? The shape of the pod, which is inflated or constricted. Then second is color of the pod is studied. Color he said green is dominant over the yellow fruit pod. So here color, I told you violet flowers dominating over white flowers. Position, what is that? We learnt the axial flowers are dominant over the terminal flowers. So all you have to count it. Then seed. What is studied? Seed. Texture of the seed. Texture, that is the round or the smooth seeds. Round and smooth are same. Dominating over the wrinkled seed. Next is about the seed color, seed coat color, where the yellow color is dominant over green color. So each 1, 2, 3 in each of these characters we study 2 different contrasting features. Therefore, among this, what is the answer? 7 pairs of contrasting traits studied by Mendel. Number of traits related to flower is 2. See 1 and 2, color and position. Second one, it is about the pod. Pod we have written shape and the color. Next is about the seed. Seed we have written again the texture and the color. 2 characters. Therefore, among all this, first option is right, saying 2, 2, 2. For each one, 2 characters is studied. Right? Therefore, option number 1 is correct. Next, 12th question. The color-based contrasting traits in 7 contrasting pairs studied by Mendel in pea plant means color-based character. What all he studied? Here only you can make out. Flower color he mentioned, pod color he mentioned, seed color he mentioned. So 3 characters he studied on color. Right? So always you have this list of all the 7 characters studied by Mendel. So answer should be 3. Right? The color-based contrasting features in 7 contrasting pairs studied by Mendel. One is flower color, one is pod color, one is seed color. So it is 3. Next, Chromosomal theory of inheritance was given by Sutton and Boveri. I mentioned it once, right? Experimental characters of the chromosomal theory of inheritance. Who did it? I told you, the scientist who is called the father of experimental genetics was Morgan. Morgan and his friends, that is B option, right? Next 15th question is to match the following. John Gregor Mendel, what he did? He gave the laws of inheritance. So A to 2. Sutton and Boveri. Sutton also I can call Sutton also. Sutton and Boveri gave chromosomal theory of inheritance. Next is Henking. He explained the X body in insects. Insect sex determination I told you. Henking. Once I explained you about the insect sex determination in insects. There I told you Henking is the name of the scientist who first discovered the sex in insects based on the presence of extra X chromosome in females which is absent in males. Therefore they will get XX and X0 sex determination. Next is Morgan. He gave, what is the Morgan? He worked on Drosophila. He is also called as the father of the fly genetics. He did all on the Drosophila. That is a Drosophila melanogaster is a fruit fly, right? So therefore, in fruit fly he studied all the major characteristics. So it is Drosophila connected to Morgan because he studied the eye color in Drosophila and also about the shape and linkage and crossing and everything worked on Drosophila melanogaster. Because very simple, it is chromosome number is 8, 2n is equal to 8, and along with that Drosophila is easily available, not costly affair, and lot of genes are almost matching with the human genes also. Therefore Morgan's work till now, it is useful for most of the other work in further genetical discoveries. Next, 16th question. X0 type of sex determination and XY type of sex determination are the examples of X0. Where we get it? X0 sex determination, it is a male. XY is also male. Therefore, it is called male heterogamety because X0 they produce two gametes, X and one is 0, which is in the insects. In humans, XY again heterogametic. One gamete will be X, one will be Y. Therefore, it is showing male heterogametic condition. We have already solved. Once again, you go through the sex determination chart. What I gave you for humans, birds, and insects. Next is genes which code for a pair of contrasting traits are known as. What do we call genes for a pair of contrasting characters? We call them as alleles. Already I told you they are found in the homologous chromosomes at a given locus. They are called alleles. It is by Mendel. Right. Here there is a question on 18th question based on the ratio. Just now I told you the ratios you have to concentrate more. First one saying dihybrid test cross. What is the dihybrid test cross? That is nothing but 1:1:1:1 ratio. Already I told you before this question. It is dihybrid test cross. Law of segregation. It is showing purity of gametes. Therefore, the law of segregation is otherwise called as the law of purity of gametes because the gametes are pure, although parents are hybrids. Law of independent assortment. You are getting 9:3:3:1 ratio, right? Therefore, that is a dihybrid. Law of independent assortment is showing 9:3:3:1 ratio. Then ABO blood group is multiple allelism. That is D2-5, right? So law of independent assortment, you need not write the 9:3:3:1 ratio. You write it as a dihybrid cross. So above all the options, A is right. A dihybrid cross, they are test cross 1:1:1:1. B they are given law of segregation, purity of gametes. Third one, law of independent assortment is connected to the dihybrid cross. ABO blood group is in multiple alleles. Therefore, option A is correct. Okay. Let's now move on to the other questions. Moving on to the next question. Actually, after the 18th question, what I gave you just now, 19th question is about sickle cell anemia. This I will explain you in the molecular biology part because it is related with the genes, the number of genes and triplet codon messaging. Therefore, anything related to sickle cell anemia and mutation disorders, I will not much explain because sickle cell anemia and all, you need to learn the details of that because that is only when you understand that you will be able to concentrate on this. So, sickle cell anemia questions I am not doing 19th and 20th. Let's go to the 21st question. Inheritance pattern of gene over generations among humans is situated by the pedigree analysis. Character study in pedigree analysis is equivalent to Mendelian traits only. They are all, we have already learned, the parents crossed and F1, F2 and all, Mendelian traits only we are concentrating on. What is true about crossing over between linked genes? Means linked genes, how they cross over. First they say there is no crossing over at all. Second says high percentage of crossing over take place. Hardly there is any crossing over. None of these. So if the genes are linked, they will hardly undergo crossing over. Normally it is not possible. But you cannot say 0%. There may be crossing over also happening in the linked genes. Therefore, hardly means sometimes very little cases are there where they undergo the crossing over. But you cannot say not at all they undergo crossing over. Therefore, C option is right. 23rd question you go through. Here you know all the diseases and their symptoms. Only one disease I did not give is phenylketonuria. That comes under genetic diseases due to mutation. Again, this comes at the end. I will explain it when I talk about the mutational disorders in human beings. Okay. So phenylketonuria, they are written urine turns black on exposure to air. Right. This word you remember. Phenylketonuria. This kind of disease is again a genetic disorder. Here actually there is a formation of phenylalanine inside. There is something wrong with the tyrosine metabolism, but they produce normal urine. There is no urine turning black color. So the one disease having black urine is called alkaptonuria. You remember this also. Alkaptonuria is the right answer for this. Therefore, phenylketonuria is not matched. Down syndrome you already know, right? What is the Down syndrome character? Down syndrome characteristic, they are saying mental retardation. You know that they have 21st trisomy. Whenever we get the disease, all the things I will explain. 21st trisomy, and they will have the Edu-Shrine because IQ is less than 20. Therefore, it is Edu-Shrine. Therefore, they will show mental retardation. This you just go through the previous class. I discussed about this. Next is Klinefelter syndrome. Klinefelter syndrome. Klinefelter. I told you what is Klinefelter syndrome. It is called XXY syndrome. Right? These are sterile males. Actually, they are not females. They are males only. I told you by birth they are males only. Only later stages there will be underdeveloped testes in them. Turner syndrome is sterile females. So among these, whichever is not matched is first one, that is phenylketonuria. Next, 24th question. Which of the following is not an example of recessive autosomal disease? It's not a autosomal. See, words you understand. Recessive autosomal disease which is not there, whatever is given below. First one is given as hemophilia. Second one is given as cystic fibrosis. Third one is phenylketonuria. The last one is sickle cell anemia. Remember, I had given you just before this some chart I given you about the recessive autosomal disorder is cystic fibrosis only. Then phenylketonuria, just now I told you, and sickle cell anemia. All the three are the recessive autosomal disorders, but hemophilia is a recessive sex-linked disease, or it is an allosomal disorder. Therefore, answer for this question is hemophilia, which is not a recessive autosomal disease. It is a recessive allosomal disease. It shows skip generation inheritance. So, the answer A is right because it doesn't belong to recessive autosomal disease. Dash pair of contrasting characters studied by Mendel pre-planned. Very simple, it is 7. Next, again, same. In dog lover, that is antirrhinum, right? In this plant, what you get is incomplete dominance because you are getting 1:2:1 as a phenotypic ratio in F2. Therefore, it is incomplete dominance. Next, I am going to talk about 28th question. Dash is the example for X-linked trait. Again, phenylketonuria, cystic fibrosis, hemophilia, and sickle cell anemia. It should be hemophilia. Now, 29th question is given. If a hemophilic man marries a carrier woman, so this thing we have not solved earlier. So let me solve this. If a hemophilic man marries a carrier woman, what happens? Whenever they ask question, don't imagine the answers. Write the cross. Right? What is the cross indicating? We are taking the hemophilic man, male, crossed with the carrier female. So, hemophilic man will be phenotypically hemophilic only. His phenotype is hemophilic, normal. Hemophilic means he is deceased. Male crossed with the female is normal looking but carrier. Normal female but carrier. What is the genotype of this? Let us cross this. Hemophilic man will have X small h and Y. Female who is carrier will have X capital H, X small h. Right? Now, during gamete formation, we will produce two types of gametes, X small h, Y, and she will produce two gametes, X capital H and X small h. Right? First, if these are the crosses, X capital H, X small h, she is a normal looking female, but she is a carrier. Right? Next cross, these two. So always take the first two crosses one side, second two crosses on the other side. Otherwise, I have seen you people are showing me the answers with all crosses one above the other, they are overlapping. Don't do that. See this. This is X small h, X small h, X small h, X small h. She is a hemophilic female. She is affected. These two crosses, X capital H Y, he is a normal and healthy man, boy, son, male. And this X small h and Y, this is again a male which is hemophilic male. This cross, once you write, it becomes easy for you. If you are finding the cross between or the marriage between hemophilic male and the normal female, then what happens is he will have an affected gene with Y chromosome. She will also have one affected gene with the normal gene. Therefore, there is a possibility that there will be one female who is carrier but look normal, but one female is affected. She will get hemophilia. I told you such females will not survive further. Next is another cross where capital H and Y crossed will be normal, but whenever small h is combining with the Y, that is the hemophilic male. Among the four possibilities, males affecting possibility 1:1, females also 1:1. Now we will go to the question. Options. Once you write the cross, options become easy for you. First option says 50% daughters are carriers and 50% are hemophilic. Second says all daughters are hemophilic. Third says all sons are hemophilic and all daughters are normal. Last says all sons are normal, all daughters are carriers. See what is that you are getting here? Hemophilic, 50% are normal, 50% are hemophilic females. Even boys are 50-50%. They are asked only females. Therefore, you should write the first option. 50% daughters and are carriers. These are carriers. See, they have X capital H, X small h. And 50% are totally affected females, hemophilic females. That's the right answer. A option is correct. So you just take the cross for color blindness and do this, right? Inheritance of which of the following trait is shown in the above cross? It is the given one is the color blindness they are given because they said this is normal carrier daughter, exactly what I gave you in the cross. So it is a X-linked recessive trait because whenever you are getting recessive traits means from father to daughter gene will go, from the daughter to the son it will go. So the cross is showing the same thing. Therefore it is the X-linked recessive trait. Next is in Mendelian dihybrid cross, when heterozygous round yellow is selfed, round green offsprings are represented by the genotype. Right? They are saying, very simple question it is. If you remember the dihybrid cross, this you take it down properly. Right? If you write the cross completely of Mendelian dihybrid cross, you can answer from the checkerboard. So observe the checkerboard and identify. So what is the question given? They are saying in this Mendelian heterozygous round yellow heterozygous is taken and it is selfed, means round yellow only. Both are heterozygous. So we will have capital R, small r, capital Y, small y. This is capital R, small r, capital Y, small y. Then what is that they are asked? That is the round green offsprings are represented by round green. The first one you see capital R, capital small r, capital Y, small y. It is round and yellow. It is not a round green. So first option is ruled out. Second option is saying capital R, small y, small y. This is the properly what they are given. Okay. So let me write them. First option they are saying capital R, small y, capital Y, small y. Capital R, small r, capital Y, capital R, capital Y, small y. See what is the characteristic? This is a round yellow. This round yellow is not that they are asking how many are. See the question, what they are asking, a round green offsprings. They are asking how many are round green. Here, how many are there? The first one itself is wrong, so first option is gone wrong. Right? Second option, this is because this is round and yellow, they are round and green. Right? Second option says capital R, small y, small y. Another one, capital R, small y. First one, small r, small y, small y. Here this is right. This is round and green, this is round and green, but this is round and this is the wrinkled and green. Therefore, this is a wrong thing. Here this is wrong, this is wrong. This is a ruled out thing, this you have to rule it out. Right? Because this is wrinkled and green. They are saying round and green they are asking. So this is not correct. Third option they are given that small r, small y, small y. Small r, small y, small y. And then they said small r, small y, small r, capital Y. Okay? Here we can rule out this because this is wrinkled and green. So this is also wrong. This is also wrinkled and yellow. These two are wrong. Therefore, this is wrong, this is wrong. Last option they are given as D option. Fourth option, capital R, small y, small y. Capital R, small y, small y. So this is round and green. This is also round and green. Therefore, both are round and green. Therefore, this is the right thing for the question. So everywhere, whenever you are writing, you have to write the cross and check it once. Otherwise, you will be imagining all the things. Don't imagine in this. These are not questions which have to be imagined like how we were doing it in reproduction, human reproduction, plant reproduction. There is nothing to memorize here. This is to solve. It's like a problem, mathematical problem. Like that, you have to solve this. Right? 32nd question. Mongolism is a genetic disorder which is caused by the presence of extra chromosomal number. Mongolism is not there. Mongoloid idiocy, right? Mongolism is not a disease. Mongolism is a genetic. Mongoloid. You just change the question there. Mongoloid idiocy, you write. Mongolism is not a disease. It's one kind of race. Mongolism is a race. Mongoloid idiocy is a disease. Therefore, you make that question, 32nd question, in your first practice corner as Mongoloid idiocy is a genetic disorder which is caused by the presence of an extra chromosome number. Where exactly extra chromosome number is found? First one is 20th chromosome. Second is 21st. Next is 17th. Third is 23. Just count it and tell me which is the chromosome number having problem there. Then it must be the 21st chromosome. So the 32nd question is 21st trisomy. Therefore, the next question I told you, Mongoloid idiocy, that is Down syndrome. You make it as Mongoloid idiocy. It is due to 21st trisomy. That's the right answer. Right? 21st chromosome. Okay, other questions we'll do later. Previous classes, whatever I have done in the concept explanation, you have understood all of that. And even I have observed that you people are writing all those crosses and showing me, many of them they have done it. That's the reason I am giving you as a homework also. Now I am continuing with some of the questions from NEET. So once I finish the NEET portions, then you will be done for the completing the principles of inheritance. After this we are going to start with molecular biology. Okay, yesterday I finished you the previous class, I think, this class, just last class I finished some of the concepts, including that I will be discussing today. That is linkage and crossing by sex determination, sex-linked inheritance and pedigree analysis. Everything will be included in this, right? So as we have finished with some of the questions already, next part I will be explaining you another question which is more connected to sex-linked inheritance. The question given is the 33rd question in your practice corner. Klinefelter syndrome is characterized by the karyotype, right? The question given is the Klinefelter syndrome. The Klinefelter syndrome, i.e. Klinefelter's syndrome. How it is characterized? What is the genotype of this? Okay, that's what they are given. Klinefelter syndrome is characterized by the karyotype. Now, one thing you already know, what is the Klinefelter syndrome? Okay, the Klinefelter syndrome is nothing but a type of allosomal aneuploidy. Okay, allosomal aneuploidy in which the chromosome number is extra along with XY. There will be XX plus 1 Y chromosome present. Therefore, the chromosomal complement 2n is equal to 44 autosomes plus XXY you will get, right? This is called allosomal trisomy. So, what are the characteristics I told you? These are because of the presence of two X chromosomes, they show feminine features. Because of a Y chromosome, they show manly features. But they are born males only. Therefore, among the given options, you will have to choose. First given is XYY, second is X0, third one is triple X, last one is XXY. So it should be XXY. And what are the other options? XYY is also given. Actually, there is one condition in which very rarely people may get XYY condition. This XYY is considered to be super male character. Super male is their point. We call it Superman, right? We call him as Superman. Sometimes there is a lot of people who have a lot of curiosity about these people. Super males are having the characteristic feature which is totally different from the normal male, and how they are produced by the unfertilized sperm with the two Y chromosome fertilizing the normal egg, right? Then if they are produced, there are some characteristic features in these people. What are those? First thing, they are normally not mingling with any of the other friends which are all males, right? And they are normally showing antisocial activities. And normally that's what is given. They are sterile in nature. Not only that, they cannot mingle with any normal people, and they are shown that they are little cruel type of characters. They are called Superman character, and they will be having a lot of very intelligent, very good looking there, right? So this is a very important feature about XYY. Same way you have triple X character also. This we call it as the superwoman character or super female character. These females are again sterile, but they are abnormal. They are not producing proper ovulation. They are not producing proper eggs, and even they are not able to produce the proper menstruation or children, right? But they have abnormality in sexual behaviors. Extremely different type of psychology they will have. So this is about the XXY, XYY, triple X chromosomes, because they are given all options. So these are also possible, but these two things you are not learning. If you want, you can go through the details of this on any of the details on Google and all. You can search. There were some movies made on super male human beings. one of them is a good son. You just watch it, because the person who is having X double Y chromosomes, they will be basically a little more cruel in nature, right? And they don't have their guy friends, male friends, and all. They don't be mixing with them, right? So that's about the question with the other answers also I gave you. Now let's move on to the next question. That is, match these column 1 with column 2. That's our 34th question. Normal woman, what is the characteristic feature, right? What is the normal woman's chromosome number, right? You must be knowing it as 46, right? So first one, A, go to third one. Then Klinefelter syndrome, how many they will have? One extra X chromosome. They should have extra 1 chromosome, means totally 2n is equal to 46, right? So what is this question saying? The 34th question, it is chromosome numbers they are given. Normal woman, how many chromosome number you will find? Chromosome number, she will be having 2n equals to 46, right, with 44 autosomes and 2 allosomes. Next is about the second one. This is A. B they are given Klinefelter syndrome. Klinefelter syndrome, they will have 2n equals 47. Why? They will have 44 autosomes plus XXY. So therefore they are having one extra allosome. That is 47 chromosomes. Then C they are showing Turner syndrome. Turner syndrome is they will be having X0 condition. Therefore they will have 2n is equal to 45. That is 44A plus X0. 44 plus 1. It is 45. You should know the details like this. Then they are given D option. Pisum sativum. How they are combined? See this. Pisum sativum. That is P plant. What is the chromosome number? It is 2n is equal to 14. Therefore, that is the option as A option, which is showing all these chromosome numbers. Actually, these are all the human beings, and this is only the plant, right? And I have underlined these things because this is the binomial nomenclature. So therefore, you have to underline them separately. That is, genus and species should be underlined separately. Other things are just common names. Therefore, I have not underlined them. So among all the options, first option is showing the right matching. So it is right. Next, they are given one question. In 4 o'clock plant, 36th question you take. In 4 o'clock plant, the gene for red flower is capital R and is incompletely dominant over the gene for white flower color, it is small r. Hence the plant heterozygous is showing pink flowers. What will be the genotype of springs in a cross between flowers, red flowers and pink flowers? So that's a nice question. You can get something, you have to extra thinking, you should do it. So what is that? I showed the incomplete dominance in this. Okay. What is incomplete dominance? Inability of a dominant character to express completely in F1. Right? So what happens here? They are saying the red flowered plant. This is the 36th question, I believe. 36th question. Red flowered plant is crossed with the white flowered plant. So you get capital R crossed with small r. Gametes you will get capital R and here is small r combined with capital R, small r. This is the genotype of F1 and it will be pink colored. Right? Now, when this pink is, they said, next character what they said, incomplete dominant, so they will have pink flowers. What will be the ratio of offsprings in a cross between red flowers and pink flowers? So, now you have to cross the red and pink. So, what are the parents? Red and pink flowers. Right? So, red genotype should be capital R, pink genotype should be capital R, small r. Right? Gamete, single gamete over here, really. There are two types of gametes. Combine these two, capital R, it should be red. This is capital R, small r, it should be pink. That is 1:1 ratio. Okay? Then, what is that they are asked? What will be the ratio of offsprings in a cross between red flowers and pink flowers? Right? If you cross the red and pink flowers, what is that ratio you are getting? See here, I said 1:1. So once you directly write the cross, you will get answer. You need not to search for other answers also. Why other three you will have to learn? In this the answer is direct. You have to get the 100% right question, right answer. For that question, the same answer will be there. For that, you have to write the cross and check. Don't do the identification, reading all the four which looks nice. No. Do the cross and you will get the answer. So you can see here 1:1 ratio is set. There is the option given here. C option, 50% red flowers, 50% pink flowers is nothing but 1:1 ratio. Therefore, that's the right answer. So I hope you understood now how to do it. Read the question carefully. Most of the students, what they do is, they read the question half the way and they leave it. Oh my God, 1:2 or 2:1 should be there. They will just guess it. Don't do that. If you guess it, then it's going wrong. You are going wrong, right? So you will have to write it as, see, they are given D option also. Red, pink, white, 1:2:1. So most of the students, incomplete dominance means it is 1:2:1 ratio. They will write it off. Therefore, think carefully and read the question carefully, then analyze the answer. Okay. Next, Mendel's work was rediscovered by 3 scientists. In which year? It's 1900. Again, there's no option here. 1900. That is where most of the discoveries of molecular biology started. Next is grasshopper is an example of a xenotype of sex discrimination, in which males have, what is the male chromosome condition? They will have one X chromosome, one Y chromosome, two X chromosomes, no X chromosome at all. Actually, I had told you there are the XX-X0 type of sex determination. They will have one X chromosome. Males will have one X, females will have two X chromosomes. Okay? Next. Let's go to the 40th question. How many types of gametes can be produced by a diploid organism who is heterozygous for 4 loci? Means for 4 alleles, how many gametes are produced? It's like a diploid dihybrid cross. You just work on it. Dihybrid cross, how many gametes can be produced if it has 4 loci? Okay. Next, what will be the distribution of phenotypic features in the first filial generation after a cross between homozygous female and heterozygous male for a single locus? Means monohybrid cross. But so whenever I say locus, means a pair of alleles, single pair of alleles or double pair of alleles. You work on that. It's simple, right? So all these crosses you can write it easily. Let's go to the different type of question. 43rd. A child has the blood group. So I am giving you next question. The child's blood group is O. Okay. Okay. So let me write. The child has a blood group. The question number is 43. Child has O blood group. Then father has A blood group. Right? Father's blood group is A. Mother is having B blood group. B blood group. Okay? Then what you have to do is work out the genotypes of the parents. Means you are given the phenotype only, blood groups only. You will have to work out for the genotype. What kind of blood group genotype they have. So what is that? This is the child, these are the parents. Okay? So father is A blood group, mother is B blood group. They have produced O blood group child. How it is possible? If father is, so possible genotypes are given, possibility. If father has IA, imagine, or IA, this is, if it is IB, then you will get AB blood group here. So for the O blood group, what we require genotype is IO, means no allele should be there. So therefore the parents cannot be homozygous for their blood groups. They should be IAIO and IBIO. Then only they can produce this combination. So what are the gametes? IA, one gamete, IO, one gamete, cross to IB, one gamete, IO, one gamete. So this IO can produce IO producing the O blood group. There may be other possibilities also, but what they have asked is, what is the type of genotype in the parental blood group? So parents are heterozygous for their blood group. They must be IAIO, IBIO. That's how you have to analyze. Because they are producing O blood group baby, that means it will be produced only when there is homozygous recessive condition. and it will receive one allele from the parent, father, one from the mother. So, if one parent is O blood group also it will not work, but they have already given that the parents are with A and B blood group. That means there should be a heterozygous for their blood group A and B. Therefore, IA, IB, IA, IO, IB, IO. Therefore, the IO, IO combined to form O blood group. So, this is how we have to guess the blood groups. Okay? Now, okay, there is one of the there is one of the 47th question, you see, because this we have done last class. That's a previously I explained you about the pedigree chart, right? So that pedigree is given here. That is in the next question. You just work out for the pedigree. I'll give you 47th question. In 47th question, what is given is which one is incorrect match, right? This I think I did not much explain you about this. I'll explain you what is this. This is called consanguineous or consanguous mating. They are given first one as a consanguineous mating. This is A option. B they are given as this way. This is a sex unspecified. Fine. The extra thing it is. And C they are given as circle male. D they are given as this affected, this affected. So affected individuals. Okay. They are asked which is not a match in this group. Means what is not right in this group what they are given. So listen, although I gave you in the pedigree chart, the male and female you know very well. That time I told you that with the basic, keeping this aside, I will give you this is the male, unaffected male, this is the female, and if they cross, there is a marriage, then it will be like this, right? And if they are having the shaded, this is the affected male. If she is affected, she is the affected female. Okay? But now something else is there. You just check it here. This is not one line. If they write one line, it is like a marriage between male and the female who are normal. Right? But if they are making two lines, it means consanguineous mating. Consanguineous mating also we call it. What is meaning of this? It means marriage. Remember, marriage in close relation. Close relation is the marriage. They marry, then it is called consanguineous mating or consanguineous marriages. Means they marry their very close relative, like maternal uncles, paternal uncles and all, if they get married, then that is called the consanguineous marriage. So this is actually right. They asked you to identify what is wrong in this. Second one is this one, which we also I didn't explain you. This is called as the sex undetermined. You are not specified any sex, means either male or male, female. It's neither male nor female. It is unspecified sex. It may be a bisexual, whatever it is. So if you write a diamond shaped thing, it is unspecified sex. Therefore, this is right. This is correct. You have to remember these two also along with the regular signs what I have given you. Male, female, marriages, affected male, affected female. Next, see they are given this as a male, this is 100% wrong. This is the female, this is wrong thing. But if they show the shaded things, they are the affected male and female. Okay, take down these also. Now, I want you to take it down. That is, you have to write about the unspecified sex in a diamond shape and the consanguineous marriage in the double line between male and female. That's called consanguineous marriage, or between the close relation there will be a marriage. Right? Then, although I told you one more thing, you remember if this is written like this, these are the twins, right? And if the twins are similar, they are called as a zygotic twins. Sometimes they are not similar, something like this. Then we write it as a non-zygotic twins. You can add that also, right? So whenever you are writing the pedigree, you remember extra things these also. Okay, make it a chart of all these signs. Okay, fine. Let's now move on to the other question. So I hope you will solve some more. So that will be your homework. So what is your homework? To solve some pedigree charts from your NEET book or your Transcend book. Right? One Transcend book already, one is already given. Just go through that. That is about the 46th question. You can solve. That will be your homework. 46th question is your homework. Okay, you do that. Because I have done it already once I explained you also. Right? Next. Refer the given statement and select the correct option. Right? You have to refer this and select the correct one. Percentage of homozygous dominant individuals obtained by selfing capital A small a individuals is 25%. Means whenever you self capital A, first option given is capital A small a if they are given. If you are selfing it, then you are getting what is that? Homozygous dominant individuals as 25%. So if you self them, do this without fail. A and small a, and small a. Right? This is AA, this is capital A small a, this is capital A small a, this is small a small a. Right? What is the ratio? This is homozygous dominant individual. These two are 50%. It's 1:2:1 ratio. Right? So homozygous individual percentage dominant parent is 25% is right. So A option is right. Right? That way every answer you just identify what is it mean by. Right? Second says types of genetically different gametes produced by genotype capital A, capital B, capital small b, capital C, capital small c is 2. Right? So second option, this is the first option they are given. Second option says that types of genetically different gametes produced capital A, capital B, small c, small c. Then genetically different gametes produced are 2. Find out the gametes in this. This is actually trihybrid cross. Anyway, how to do the trihybrid cross? Now we can easily make A, B, small c one gamete, A, small b, small c one gamete. Okay. Then how many are heterozygous? See, this is actually a trihybrid cross. I would like to give you before this some background about the trihybrid cross. I will give you. To explain this, I will explain you the trihybrid cross. Okay. How do you write the trihybrid cross? Okay. Keep this aside. Now I will give you trihybrid cross. So many questions will appear. Imagine a cross for 3 pairs of alleles. Okay. Imagine it is AA, BB, CC cross to AA, BB, CC. Okay. This is a trihybrid cross. Okay, having 3 pairs of alleles. So gametes, when you write, it will be A, B, C here. Here it will be A, B, C. Okay, small c like this. Combine it. Capital A, capital B, capital A, small a, capital B, small b, capital C, small c. Okay. Now self them. Then you will get the gametes. Okay. On selfing, this is F1, right? On selfing F1. What you will write? This is self. Right? So let me write the gametes of the selfed character. Right? How do you write? First is A. You write this one, capital B, small b, because there will be 2 parents, right? AA, BB, CC cross to AA, BB, CC. For each gamete you should write like this. Right? Then B, capital C, small c. Here again capital C, small c. Okay? This is one. Next you take small a. This is capital A, small a. Small a with capital B, small b. Capital C, small c. Again capital C, small c. Then the gametes. A, B, C. Capital A, capital B, capital C, one gamete. capital A, capital B, small c, one gamete. Then capital A, small b, capital C, one gamete. Capital A, small b, small c, one gamete. Small a, capital B, capital C, one gamete. Small a, capital B, small c, one gamete. Next is small a, small b, capital C, one gamete. Small a, small b, small c, one gamete. See how many gametes? 2, 3, 4, 5, 6, 7, 8. 8 gametes. One side, 8 gametes another side. Then you will have to write a checkerboard. That's a trihybrid cross. So that also you can make it as a homework. How to write the gametes and write the checkerboard. And this question you can solve, right? Because it's on the trihybrid cross. They are asking how many heterozygous combinations are produced. Okay? Right. So this I want you to solve because it's showing capital A, capital B, small b, small c. There are two gametes. Types of genetically different gametes produced are of two types. You must be knowing capital A, capital B, small c, one gamete, capital A, small b, small c, one gamete. So there are two possibilities. Then phenotypic ratio of monohybrid F2 progeny in mirabilis jalapa is 3:1 is wrong. Because in monohybrid F2 mirabilis jalapa is showing incomplete dominance. Therefore you will get 1:2:1 ratio. So all the statements are true is wrong. Statement 1 and 2 are true, correct. Statement 3 is false, is right. B option is right in this. Okay. Now, next, 49 question. Father of a child is colorblind and mother is carrier for the colorblindness. Okay. So, let us work out the cross. So, first you write this down. This you take it down because this will help you to write polyhybrid crosses. Okay, if you are done with this, let's move on to the next one. So one last question let me deal with. They said that the father of a child is colorblind. Okay, so there is one child. The father is, the male is colorblind. Then what they said, and mother is carrier. Mother is a carrier. Okay. Then what they said, the probability of child becoming colorblind and probability of, first you will write the genotypes. Father is colorblind means he will have X, small c and Y. This is genotype. You should understand what is genotype because he is colorblind. He will have small c. Mother is a carrier. She will be X capital C, X small c. Right? The crosses, gametes, X small c and Y. She will be X capital C and X small c. First combination, these two combinations, X capital C, X small c. Second combination, X small c, X small c. This combination, X capital C and Y chromosome. This is X small c and Y chromosome. So who are these? This is the normal female but carrier. Carrier but normal female. This is the colorblind female. This is the normal male. This is the colorblind male. Okay. Now see the question. They said that the probability of child being colorblind. The probability of child being colorblind is, means child getting colorblind percentage. What is the percentage of child getting colorblindness? See, one colorblind child is there, another colorblind child is there. So possibility of colorblindness is 50% because remaining is the normal ones. Therefore, they have asked of 25, 50%, 100%, 75%. What you will write? You will write 50%. So whatever they ask, remember, remaining you solve and ask me the doubts. Whatever they ask, you are supposed to make one cross like this. Then you will get the answer without even referring what are the options given, you will get an answer. This way you solve all of them. I hope you will be doing wonderfully well. Mendelian inheritance is a scoring subject. A lot of questions come from that. I want you to work out all the neat problems from that. Okay? Done then. So that's a completion of Mendelian inheritance.